This is Newton's second law. What it says is this. The net external force acting on an object is just equal to the mass of the object multiplied by the acceleration of the object. This law tells us several things. One thing it tells us is the acceleration of an object is pointed in the same direction as the net force acting on the object. And it also tells us some other things. So to determine what else Newton's second law tells us, let's go ahead and translate Newton's second law from math, as it's written now, to English. So to translate this to English, this sigma F means net force, or the net force acting on whatever object or system we're concerned with. So net external force equals the mass of whatever object we're concerned with or studying multiplied by the acceleration of the object. So that's Newton's second law written in English. So what we're going to do now is we're going to take Newton's second law and we're going to solve for acceleration, or we're going to get acceleration alone. To do that, we're going to divide both sides of the equal sign by mass. So let's go ahead and do that. Let's divide both sides by mass. So let's get our divided by sign over here. Divided by mass. We don't need our multiplication sign anymore. Get rid of that. And so we're left with acceleration on the right-hand side of the equal sign. What this says now is acceleration equals net external force acting on an object divided by the mass of the object. What in the world does that mean? Here's what it means. What that says is the acceleration of an object is directly proportional to the total net external force acting on the object and inversely proportional to the mass of the object. So what that actually means in human terms is if you push harder on an object, if you exert a greater force, a larger force on an object, it will accelerate more. And it also says if you push more softly on an object, it will accelerate less. That's what acceleration is directly proportional to force means. But this also has this little part, inversely proportional to mass. So acceleration is inversely proportional to mass. What that means is if you push a bigger object, an object with larger mass, it will accelerate less. So if you push on an elephant, it won't accelerate very much. And if you push on a less massive object, a smaller object like a baby, for instance, it will accelerate more.